This is a solution video for Algebra 3 proving abstract inequalities, and I'm looking at page 474, question 18 in text and test 4. In this question we're asked to prove that the square root of AB is greater than 2AB over A plus B, and there's a couple of restrictions in the question. We're told that A and B are both positive, and that'll be useful a little bit later on. And we're also told that A is not equal to B, which won't really have a huge bearing on how we go about the question. It's just to avoid us square rooting to get an answer of A or B. So let's start with the assumption that this statement is true, and then let's see, can we work it on to any statement that we can definitely verify is correct. That then will allow us to conclude that the initial statement is verifiable. So I'm going to start by saying if root AB is greater than 2AB over A plus B. So I'm making the assumption that it's correct initially, and then I'll work with that. So I'll say then, okay, so what can I do? Well, if the left-hand side is bigger than the right-hand side at the moment, then I can square and retain that characteristic. So I'm going to square both sides of the inequality. And the reason that I can do this is because it does actually work with numbers. So say, for example, if I had 3 is greater than 2, well, if I square both sides, so I've got 3 squared and I've got 2 squared, well, the inequality still stands because 9 is still greater than 4. So I can square both sides and the inequality won't get affected. This works in the case where the two numbers involved are positive numbers, okay? And so that's why they've given us that piece of information starting out that A and B are greater than 0. Just note, as a little aside, that if I had -1, which is greater than -2, because it's further to the right on the number line than -2 is, if I square both sides in that case, I get 1 and 4. And clearly, 1 is less than 4. So it works in the case where the numbers involved are greater than 0. So we have that in our setup, so we're happy to proceed. So I'm squaring both sides, squaring the left, I'm getting AB. And then squaring on the right-hand side, I'm getting 4A squared B squared over A squared plus 2AB plus B squared, and just take care there with that multiplication of squaring at the bottom, okay? So I'm going to try and get rid of the fractions in this, and I'll probably bring my denominator here from the right-hand side up and multiply on the left. But I'm just looking at that in advance and thinking, oh God, I'm going to end up with A cubes, and that's a bit of a nuisance. So could I do anything to kind of avoid that scenario, as it were? So I can actually, because what I can do is I can bring this up to the left and multiply, but I can also bring the AB down onto the denominator on the right-hand side. So here's what I'm going to do. I'm going to first of all just call this 1AB to make it nice and clear what's going on. And then I'm going to bring my A squared plus 2AB plus B squared up and multiply it. And you'll notice that I haven't written down my AB, and that's because I'm going to bring that over onto the right-hand side and divide. Now, I do have to be careful with inequalities, moving things across the inequality to divide, because again, the inequality symbol will get affected if I'm dividing or multiplying by a negative. But again, that's the reason that they've given me this fact at the beginning that A and B are positive. So I don't have a problem bringing the AB across and dividing, and I don't have a problem bringing this information up here and multiplying. Okay, so now I'll tidy up a little bit, and this will turn out quite nicely actually, because well, on the left hand side I've got obviously my bracket will just stay as it is pretty much, and on the right hand side I'll be able to simplify slightly. So I won't be going into the A cube and B cube territory. I'll actually be sticking with A squareds, A's and B's. So my line now reads A squared plus 2AB plus B squared is greater than 4AB, and this looks a lot simpler than what we started out with. And so what I'm going to do next is bring everything to one side of my inequality and get a 0 on the right hand side. And when I do this, I can simplify a little bit because I've got my two terms here, 2AB and minus 4AB. And that's giving me A squared minus 2AB plus B squared is greater than 0. Okay, so fairly frequently in these kinds of questions, I end up looking to see if there's any squaring occurring in the question. And I try to take expressions like I have on the left-hand side here and write them as squares in brackets. And that tends to happen when I want to prove that something is greater than 0. Okay, and if something is greater than 0, it's obviously positive. So if I can get a square, well, a square is definitely positive, so I'll know that my statement is definitely greater than 0. So if I look at my left-hand side here, A squared minus 2AB plus B squared should look fairly recognisably like A minus B squared. So I'm going to just change it into that format, A minus B squared. And if you want to convince yourself that these two lines are the same, you can multiply this line out. But you might even notice there's a bit of a similarity here between what happened when I squared A plus B and got A squared plus 2AB plus B squared, and what happens when I square A minus B to get A squared minus 2AB plus B squared. Okay, So they're kind of in the same family, if you like. And when I get as far as this line here, I can say, well, okay, this statement that I've got to here is absolutely certainly true because I've got some term here being squared. And so when I square a value, well, it's going to be greater than 0, particularly when the a and b values themselves are not equal and are greater than 0. So I'm going to be able to say that this line is definitely true. And since this series of logical statements took me from this first line to this definitely true line, it means that this first line must be correct. So I can conclude then by stating that therefore the root of ab is greater than 2ab over a plus b.